The Tiltrotor helicopter is one of the most fascinating innovations in modern aviation, combining the vertical takeoff and landing capabilities of a helicopter with the high-speed and long-range performance of a fixed-wing aircraft. This hybrid aircraft design has opened up entirely new possibilities in both military and civilian aviation, offering versatility that neither traditional helicopters nor airplanes can achieve alone. Its unique ability to transition mid-flight between rotor-borne lift and fixed-wing forward flight makes it a marvel of engineering, and understanding how it works helps us appreciate the incredible technology behind it. At the heart of a Tiltrotor helicopter's operation are its rotating nacelle engine pods mounted on the ends of the wings, each housing a powerful engine and rotor system. During takeoff and landing, the nacelles are positioned vertically, functioning just like a helicopter's rotors to provide lift. Once airborne, the nacelles slowly tilt forward, transitioning the aircraft into horizontal flight mode. In this airplane-like configuration, the rotors act like propellers, providing thrust while the fixed wings take over the job of providing lift. This transition allows the Tiltrotor to fly much faster and farther than conventional helicopters. One of the most well-known examples of a Tiltrotor aircraft is the Bell V-22 Osprey, which has been in service with the U.S. military for years. The V-22 is capable of reaching speeds over 300 miles per hour and has a range of more than 1,000 miles, far surpassing the capabilities of traditional helicopters. The aircraft is primarily used for troop transport, medical evacuation, and logistical support, and has proven its worth in combat and humanitarian missions alike. Its ability to take off from aircraft carriers or unprepared fields and then transition into fast-forward flight makes it uniquely suited for rapid response operations across varied terrains. Engineering a Tiltrotor aircraft is no simple task. The transition from vertical to horizontal flight introduces a host of aerodynamic and mechanical challenges. Synchronizing the rotors, managing power between engines, and maintaining stability throughout the transition are all complex tasks requiring precise control systems. To make this possible, Tiltrotor helicopters are equipped with sophisticated fly-by-wire systems that automatically adjust rotor speed, blade angle, and engine output to ensure smooth transitions. Pilots are trained to handle these dynamics, but much of the process is managed by onboard computers, ensuring safety and performance in a variety of flight conditions. The versatility of Tiltrotors makes them appealing not only for military applications but also for future commercial use. Several aerospace companies are exploring Tiltrotor technology for urban air mobility, cargo transport, and even passenger flights. The idea is to create a new category of aircraft capable of operating in densely populated areas without the need for runways, yet still delivering the speed and efficiency of airplanes. This could revolutionize travel between cities, islands, or remote regions where conventional infrastructure is lacking. In emergency situations, such aircraft could rapidly deliver medical supplies or evacuate people from disaster zones. From an engineering perspective, Tiltrotors offer a unique blend of innovation. The rotors themselves are larger than those on most helicopters, giving them the ability to lift heavy loads vertically. At the same time, their transition to a fixed-wing configuration means less fuel is used in cruise flight compared to hovering or forward-flight helicopters. This efficiency can translate into reduced operational costs and greater mission flexibility. However, it also requires careful balance and load management. The aircraft's center of gravity, wing loading, and rotor thrust must all be finely tuned to allow seamless transitions and stable flight in both modes. Noise is another consideration in Tiltrotor design. While quieter than jet engines in some ways, Tiltrotors still produce significant rotor noise, especially during takeoff and landing. Engineers are working on new blade designs and advanced materials to help reduce this noise footprint, which will be critical for integrating Tiltrotors into urban environments. Additionally, advances in battery and hybrid propulsion systems could one day power electric Tiltrotors, making them cleaner, quieter, and more sustainable. As technology advances, we are beginning to see more experimental and next-generation Tiltrotor prototypes take to the skies. The Bell V-280 is one such example, developed as a successor to the V-22 with greater speed, range, and agility. Its streamlined design and digital flight controls promise even better performance, highlighting how far this technology can go. Meanwhile, companies like Leonardo are developing civilian tiltrotors like the AW609, which aim to provide high-speed transport for business travelers, emergency responders, and VIPs. In conclusion, Tiltrotor helicopters represent a groundbreaking fusion of helicopter and airplane technology, offering capabilities that were once thought impossible. They are faster, more flexible, and more capable than many of their conventional counterparts. As research continues and the technology matures, we are likely to see Tiltrotors play an increasingly prominent role in how we move people and goods through the air. Whether it's flying soldiers into combat, rescuing civilians from hard-to-reach places, or enabling next-generation air taxis, Tiltrotor helicopters are truly at the cutting edge of aviation innovation.